Good morning, my good students. Today we're on lesson 4 of chapter 9. We're going to talk about scatter plots and trend lines. We're going to talk about how do you create a scatter plot, that is, put a dot for every data on a graph, and then how do you draw a trend line to show the general trend that the data is showing in your graph. So let's get started. As we begin, let's look at a simple problem. The problem at the right shows the number of digital albums downloaded per year and the number of CDs sold by a manufacturer per year. What's the relationship? Is there a relationship that exists between the two sets of data? And can you predict the number of CDs sold and the number of albums sold in 2010? In other words, you have two sets of data. First of all, you have the data showing the albums actually being sold each year. You can see 4.6, 13.6, 27, and you can see the number as it's going up. These are the albums that are being downloaded. So what you see is a growing trend of people who are actually downloading their music directly on their devices, whereas back in this time there were a lot of people who simply used to buy the music, and so you actually bought the CD, and you see that number is going down. And so we're just trying to compare these things and see what we can see. So first off, notice that the digital albums are going up, but the CDs are going down. Okay. So let me draw a graph. I want to draw a graph, and I'm going to make a graph, a scatter plot, where I'm going to let X be the albums being downloaded, and Y be the CDs in the different years, and see how they compare. And so as I just graph them, I get these points here. And notice if I draw a line through it just to try to estimate it, notice that as the number of downloads increase, the number of CDs sold decrease, which probably indicates that as people begin more and more to simply download them, pay to buy them just downloaded, then they're not going ahead and buying the CD. So it makes sense. Let's just calculate the average rate. We want to make a prediction for the year 2010. So what we're going to do is we're going to calculate the average rate and then extend it out to make a prediction. So for example, for the downloads, if I pick 2 points, if I pick 42.5 and 46, and that's 42.5 minus 4.6, and I divide it by 207 minus 43, I see that thing is going down about 12.6 million per year. Okay, so that's my average rate. Now, we want to predict what it's going to be in 2010. Well, in 2010, it's going to be another 32 years. So if I take the 42 plus 5 plus I take 3 times this much that it's going up each year, I find out that I can make a prediction that in 2010 they'll be selling about 80 million downloaded albums. Let's do the same thing with the CDs. Now they're going down. Okay, so in their case, if I take 511, 671, notice that it went down. It's going down 85 million per year. Now we're at 511, okay? And if we subtract 85.3, again, 3 times because I'm going 7, 8, 9, 10, I can see that by 2010, we will be selling, it'll be down to about 255 million. Notice they're still selling more CDs than they are albums. There's still a market for people who want to actually own the music and be able to play it on their CD, etc. Okay? Let's do a little vocabulary, things that we're going to have today in our lesson. First of all, notice scatter plot. That's what we drew in the thing with the albums and the CDs. It's a graph that relates 2 different sets of data by displaying them as ordered pairs. In our case, you see, we compared the downloads to the CDs. Here they're comparing advertising to sales. Okay. A trend line, the next thing, trend line is the line on the scatter plot near to the points. It shows perhaps a correlation. you try to draw a line that is kind of equidistant from all the points as best as possible. The equation line of best fit is an equation that represents a line that predicts values outside the given area. It's the one that best comes closest to all the lines. And we've discussed this before in a prior chapter. But if you have a line of best fit, you can use it to make predictions outside of your area. Next, we have the correlation coefficient. This is a new concept. Notice it's some number between -1 and 1. And it tells you how closely the equation of the line best fits the data. And we'll get into that in a moment. The negative and positive have to do with correlation. If you're close to 1, your line is really close to the data in a positive direction. If you're close to -1, you're really close to the data, but it's going down. If you're close to 0, it means there's very little correlation between the data. The last concept we have is causation. That's when one quantity actually causes a change in the second quantity. Sometimes data looks like they're correlated, but there's no relationship between them. We could say something like, well, if I exercise, I'll lose weight. Well, hopefully there's a cause there, and so that's causation. Does one variable actually cause the other to change? So when we look at scatter plots and correlation, we have 3 ways that we can describe the correlation of their data. First is positive. Notice the positive. One easy way to remember this is draw your line and then ask, what's the slope? Is it positive or negative? Notice that has a positive slope, and a positive slope means that as y increases, as x increases, y increases. Has a positive slope. Likewise, the second one, a negative correlation. Notice if I draw the line, it's a negative slope line. Okay, it means that as x increases, y decreases. It has a negative slope. So in the positive, they go up together, so to speak. In the negative, as x goes up, y goes down. The last one, you see, I cannot quite sure where I might draw that line. It's not clear, and that's because there is no correlation. There's no pattern at all. So let's make our first scatter plot. Here we have data has to do with the weight of a baby panda based upon how many months old it is and what its weight is. So what we do is we're going to take age, going to put it at the bottom as our x variable. We're going to let this be our x and this be our y, so our weight's over here. And now we just plot the points. At age 1, it is 2.5 pounds. At age 2, 7.6. 3, 12.5. 4, 17.1. 6, 24.3. 8, we have 37.9. 10, 49.2. And 12 is 54. So that's our general scatter plot. You can take a look at that. Almost a straight line, but in real life when you're taking data, it's not always, very rarely is it exactly a straight line. Some of that has to do with human beings measuring it, but there's all kinds of other factors that make it close, but not always exact. And there's a sample of a line I might draw as a line of best fit. What I think comes close to, you see it touches most of the lines, and it's pretty close to the other lines as well. Now, describe the relationship between the age and the weight of the panda. As it gets older, what happens to its weight? As the age increases this way, the weight is going up. All right? So that's the relationship. The weight of a panda increases as it gets older, as the age increases. So what kind of correlation is this? This is positive correlation. Okay? Positive because as the age increases, the x increases, the y increases as well. Is there a causal relationship between the weight of the panda and the age of the panda? Yes. As the panda gets older, it naturally, as it gets older, as it eats, it naturally grows. So there is a causal relationship between the weight of a panda and the age of a panda. Now, the next thing we want to do is actually calculate. If we want to use a prediction, it was nice to have that line, but we need to actually be able to calculate that line. So I want to give you some steps, 5 steps on how to write the equation of that line. This should be familiar to you. If you go back a couple chapters when we talked about how do you write the equation of a line between 2 points, that's all we're doing here. We're just taking 2 points from our graph. So the first thing we do is we use the coordinates of 2 points in the graph. Typically, we want to find 2 points that are either on or very close to the trend line that we've drawn. All right, and we'll label them x1, y1, and x2, y2. Then we're going to use the slope formula to find the slope of the 2 points. Okay, look down below here. You remember how to find the slope? You find the change in y over the change in x, the rise over the run. Then once we find the slope, then we're going to write the equation in the point slope form. Point slope form looks like this. We'll now have our slope, and we'll pick 1 point to put in there. All right. Then once we do that, we're going to rewrite the equation into this form, y equals mx plus b, and that will be the equation that we can use to make predictions. So let's apply this procedure to our weight of a panda data. So the first thing we want to do is pick 2 points close to the line. So you notice the 2 points that I've picked. I've picked the points 4, 17.1, and the points 8, 37.9. Again, I just picked 2 points that were close to the line. So step 2 is to find the slope. So first I picked my 2 points. Now I find the slope. 37.9 minus 17.1, the change in y, divided by the change in x, 8 minus 4. And so I get about 5.2 is my slope. That's the slope of my trend line. Next point, let's put that slope and one of the points into the point slope form. So I chose the first point simply because it's smaller numbers. There's my y1 and my x. And now I have it in that form, so let's solve it for y. So I'm going to distribute here, and now undo the minus 17.1 by adding it to both sides, and I arrive at my equation, and this is the equation for my trend line. Again, this is the same procedure we used a couple of chapters back when we taught you how to write the equation of a line if you have 2 points. You pick 2 points, you find the slope, you put it in the point slope form, and then you rewrite it into the slope intercept form. Now we can use this to make some predictions. One of the predictions we can make, this first one is something we call interpolation. The reason it's called interpolation is because we're trying to find out 7 months, which is in the middle of our data. So we're just trying to make an estimate of something in the middle of our data already, all right? So what I have to do now is take my equation and simply plug in for x, put in 7, okay, because it's going by the month, and now we just algebraically solve it. So that's 36.4 minus 3.7, and it would be about 32.7 pounds. If you look up here, 32.7, yep, that fits between there and it looks good. The next one, 14, is actually bigger. At this point, we're doing something called extrapolation. Extrapolation means we're going beyond our data. The reason it's called that is because sometimes when you extrapolate, you can't always trust it. You know, the case of a panda bear, even though this baby panda is growing at this rate, it doesn't continue to grow that rate all its life. At a certain point, it begins to level off. So you always have to be a little careful of extrapolation. I don't think 2 months is going to be a problem, but let's figure it out anyway. So now I put 14 in there. And so multiply that out. Subtract it. And at 14 pounds, we expect it to weigh 69.1. So that's not bad. It seems to be appropriate. So that's how we would find the trend line, and that's how we would use it to make a prediction. So let's try a couple of samples here just to see if we have the idea. First of all, if I look at the first one, I can kind of draw a line. Now what that tells me is that a positive or negative slope. It's negative, so as I look at my possibilities, I already know, since it has to be negative, that this one and this one don't work. So my choice is between one that's real close to -1 or one here that is 900ths is actually close to 0. So the question now is, are the points close to the line or not close to the line? And I would say they're pretty close to the line. So in this case, I would choose this is a strong correlation, strong positive correlation, strong negative correlation. And so I would go with R at minus 9/10, close to 1. The second one, this one is positive, but notice it's not as strong. The points are not as close to the line as they were in the first example. So first off, it is positive, so I immediately know the negative ones are wrong. So I can say that one's going to be wrong, and that one's going to be wrong. So my choice is between 0.7 or 0.07. Well, this one's close to 0. This one is moving towards the 1. It's not as close, but that's what we're after. It's going to be a positive correlation, so it has to be plus. And while it's not like a 9, it is fairly close. So I would say it's a strong correlation, points are close, and in this case our answer is going to be 7/10. In our last one, we're looking very little correlation there. Okay, I say positive, but I could almost have drawn the line this way too and said it's that way too. So I'm looking for a number that's close to 0. Okay, so no pattern. Which one's the closest to 0? 1/100th. That's the closest to 0. The last thing we want to talk about in our lesson today is causation. Causation is when a change in one quantity actually causes a change in a second quantity. A correlation between quantities does not always imply causation. That's something you have to sort of keep in mind as you study statistics. Sometimes you'll find things that are correlated, they seem to go together, but there may be no cause between them. And often people will make that mistake and think they are. So in the next one, we want to identify whether the relationships are causal. And in the following situation, is there likely to be a correlation? And if so, does it reflect a causal relationship? So, first one, just as an example, if the number of loaves of bread baked and the amount of flour used, what do you think? Is the more flour I use mean the more bread I bake? Sure seems like it, doesn't it? There is a positive correlation and there's a causal relationship. I don't bake bread without flour, so the more flour I have, the more bread I have. The flour actually causes the bread. So as the number of loaves increases, the amount of flour we use increases. There's a positive correlation and a causal relationship. B, the number of mailboxes and the number of firefighters in a city. This is interesting. Interesting thing is, why does a city increase its firefighters? Well, we usually get more firefighters as the city grows. You know, like in our Clovis East area, we're building houses all the time. And it's growing and growing and just filling up our school. Well, because it's filling up our school, we also have to build another fire station, and so we have to hire more firemen. So in a sense, as our city grows, we need more firefighters. Well, when we build these houses, guess what they have? Mailboxes. So notice that as the mailboxes grow, so do the firefighters. But are they causal? Does building a mailbox mean that we're automatically, that causes us to have more firemen? And the answer there is no. There's very likely that we're going to have a positive correlation. As the mailboxes grow or as houses are built, we'll have to add firefighters. But the mailboxes do not cause the firefighters. I can't walk across the street and build 200 mailboxes and think, oh, now there'll be another 5 firefighters. It doesn't work that way. The two things go together correlation-wise, but one does not cause the other. So on to your notes. Does the situation seem to have positive correlation, negative correlation, or no correlation? And if there is a correlation, is it causal? A person's height and their shoe size. Do people who are taller tend to have bigger feet? Well, the answer there is probably yes. Not absolutely, but generally speaking, your feet get bigger and you get bigger. All right? So we would think there's a positive correlation, but not necessarily causation. All right? Your getting bigger does not cause your feet to get bigger. We just tend to think that they are getting bigger. How about the number of hours spent reading and the number of books you read? Now that one seems pretty simple. If I'm reading and reading and reading, then it seems like the more I'm reading, the more books I'm reading. So those two are definitely related. There's a positive correlation, and my reading does imply causation. 5, the number of pets a family owns and the height of the tallest family member. All right, so does the number of animals you have at your house increase the height of the tallest person in your family? You're going, what? Of course not. There's no relationship. In this case, we would say there's no correlation between the number of animals you have in your house and how tall the tallest person in your family is. The last one, the number of car accidents you cause and your insurance rate. This one might be hard simply because you may not at this point understand or have ever had to pay insurance. Your parents, when you start to drive, have to buy insurance in case you're in an accident, so it will be covered. And the price of that insurance is based on a lot of factors. One of the things your parents discover right away is because you're a teenage driver and teenage drivers have more accidents, it costs more money to insure a teenager than it does an adult. Likewise, once you have insurance, if you start having a couple of accidents, then the insurance companies go, hey, this guy's not a good driver, and your insurance will go up. So in this case, if I start having accidents and I cause them, my insurance rate is going to go up. All right. So there is a positive correlation here, and there is a causation. Having more accidents is going to end up causing my insurance rates to go up. All right, guys, have a great day, and we will see you at the tutorial maybe tomorrow. Thank you.